Tandem lifting looks simple on paper, but in the field, physics can turn a routine lift into a disaster in seconds.
When a load swings, it generates a shock load. This is the dynamic load factor. Suddenly, your cranes are fighting a weight they weren't built to handle.
Why tandem lifting fails? The importance of dynamic load factor. A 60-ton load was planned to be lifted using 2 cranes. During the lift, each crane was intended to carry approximately 30 tons. And according to the crane load charts, both cranes were operating at around 70% of their rated capacity. The lift appeared safe on paper. However, as the load was lifted, it started to swing unexpectedly due to wind, sudden boom movement, or uneven hoisting speed. This created a dynamic load. Instead of sharing the load equally, one crane suddenly took a much higher percentage of the load, while the other crane took less. Within seconds, one crane exceeded its safe working capacity. The crane lost stability and tipped over. The sudden transfer of load caused the second crane to overturn as well. Why did this happen? The lift plan considered only the static load. It did not account for dynamic load factor, which occurs when the load swings, snatches, stops suddenly, accelerates or decelerates quickly, is affected by wind, is lifted unevenly by 2 cranes. These dynamic forces can increase the actual load on a crane above the calculated static weight. Dynamic load factor. Industry standards require additional allowances for dynamic loading during critical lifting operations. Typical values used in engineering and lifting plans are DLF equals 1.25 for controlled heavy lifts under normal conditions, DLF equals 1.50 for tandem lifts, complex lifts, or where there is a higher risk of shock loading and load transfer. Example, static load equals 60 tons. With DLF 1.25, design load equals 75 tons. With DLF 1.50, design load equals 90 tons. This demonstrates why a lift that appears to be within the crane's capacity can become unsafe once dynamic forces are introduced. Why tandem lifts are more dangerous. In a tandem lift, the load is rarely shared exactly 50-50. Even a small swing can transfer several tons from one crane to the other. Different boom deflections change the load distribution. Uneven hoisting speed causes sudden load transfer. Operator timing differences increase shock loading. Wind can rapidly alter the load balance. This is why tandem lifting is considered one of the highest risk lifting operations. How to prevent tandem lift failure? Prepare a detailed tandem lift plan. Carry out a comprehensive risk assessment and job safety analysis. Apply the correct dynamic load factor during lift planning. Verify crane capacities using the worst-case loading condition. Ensure load sharing calculations are checked by a competent, appointed person or lift planner. Conduct a pre-lift coordination meeting with all personnel. Use experienced crane operators, riggers, signalers, and a competent lifting supervisor. Lift slowly to avoid shock loading. Continuously monitor load balance and sling angles. Stop the lift immediately if any unexpected load movement or swing occurs.